Let's take a look at recognizing when you have an augmented matrix that has been row reduced, um, whether you have no solutions or infinitely many solutions. All right, so here's the question we're looking at. And while you're taking that in, I'm going to read something back here. Let's see here. Right. About halfway copied. All right. Get that zoomed in on. Give me just a moment here. In the first one, we had, besides the augmentation row, column, we had 3 rows and 3 columns besides the augmentation, which means we're looking at the intersection of 3 planes, unless there are either no solutions or infinitely many solutions. And if I think of the first column as having stood for X, the second column standing for Y, and the third column standing for Z, then I could translate back from the augmented matrix into this 3x3 system of equations. Some of you may have focused in on the last part, because that would just simplify to 0 equals 0, which is a true statement. However, the row above it would simplify to 0 equals 15. And that is false. So we started off with the assumption that the 3 planes were going to intersect at a single point. And when you get an untrue statement here, that means we have to trace back to an untrue assumption so that there are going to be no solutions. On the second example, we only have this weird column, weird row here, which is going to simplify to 0 equals 0. That's a true statement. No problem with this. So we are going to have infinitely many solutions on that one. So let me bring back up the share. In case you didn't catch what I was saying out loud, then you'll see it typed in just a moment. There we go. The first one, no solutions. The second, infinitely many solutions. Hope that helps.